In this video, we are going to study the implementation and functioning of memory read operation or micro operation that is performed in the CPU. So let's look at the schematic for memory read operation. We can see three different buses here. The first one is nothing but internal CPU bus, the yellow one, and the other two buses are memory address bus and memory data bus that connect the external memory to the CPU. So let's label them. We have two registers here, R1, R2 general purpose registers with the control signals, two control signals for in and out operations. Then the registers that are used in the memory read operations or memory operations are memory address register and memory buffer register. The control signal for the memory address register is only the memory address MAR in. So there is no MAR out signal, control signal. So the memory address register is directly connected to the memory address bus. So whenever the address is placed in the MAR, it is immediately forwarded to the memory. Now, the MBR or the memory buffer register is for the storing temporary data that is read from the memory or which is to be written to the memory location. So the control signals are two-way control signals are present here. That is the in and out signal for connecting it to the CPU bus and in-out signal connecting it to the external data bus. So I hope you have understood all the control signals. There is one other control signal which is not shown here, that is WMFC. Now the significance of which we will see during the operation. Okay, so let's take an example and see how it works. So suppose we want to read the data from the memory at the location whose address is stored in R1. So R1 contains the address of the memory location and we want to read the data from that location and put it in the register R2. So this is what we want to perform here. Now we know how different T states and the different operations that are to be performed. So let's start by setting the appropriate control signals. In the first T state, the R1 out is set and MAR in is also set. This means the data from the R1 is put on the CPU bus and then goes to MAR. So basically the address of the memory location is present now in the MAR and it is immediately forwarded to the memory address bus. So now in this T state, the memory address bus is active, and in the next T state, we want to activate MBRE in signal and the another signal we talked about before, WMFC control signal. So what does this control signal do? Now note here that the external memories are often slower than the processor speed. So it is going to take more than one T states or more than one processor clock cycles to fetch the data from the memory. The WMFC signal indicates that the CPU has to wait till the data is fetched from the memory. So we are activating this signal. That means the CPU will remain in T2 state till WMFC or the data is fetched from the memory. So basically here we are activating the input signal, input control signal to the memory buffer register and we are waiting for the data to come. Until that, we are going to stay in the T2 state. Now, in the next state, when the data comes to the memory buffer register, we are going to set memory buffer register out signal high. That means the data coming to the memory buffer register goes to the CPU bus and R2 in is also on. It is read by the R2 register. So in this way, the data is transferred to the R2 register in the third T state. So we have seen the complete memory read operation. I hope you have understood all the terminologies and the functioning of during each T state. Let's look at the timing diagram to understand it better.